Hello everyone, welcome to another example of Keplerian-Lagrangian method. In this tutorial I'm going to show you how to simulate a bird struck on the wing using a CEL method. So what we're going to have here, we're going to have a Eulerian domain, and then we're going to have a wing and a bird. So for Eulerian domain, we're not going to define any material, we're going to consider it as a void. And the bird, we're going to use the equation of the state for this one, and then we're going to give a movement to it. And for a wing, we're going to use it as a single part and made out of aluminium. And what you're going to expect here in the result, so here we're going to have wing and then bird, and the impact happen, and as you can see, the damage on the wing. Of course, the damage maybe in reality wouldn't be that big, but we use the material property with some estimation for damage evaluation, so that's why the damage is quite big in the last step. So for this tutorial, what you need to know about Johnson-Cook damage model and also equation of the state, and hopefully you have done a previous example about CEL method, because in this tutorial I'm gonna do this step slightly quicker than before. So if you're ready, let's do this one in Abaqus. So now I'm gonna show you how to simulate a bird strike on a wing using a Keplerian-Lagrangian method. First, I'm gonna import a cat file, wing cat file. So I'm gonna go to part, import, and then I'm gonna add this file. Well, you can download this file from the resources section under this tutorial in Udemy. Save it on your C drive and then set the file filter to step. Click on this one and then click on OK. And then here, click on combine into a single part. So we're going to bring it as a single part. If you bring it as individual parts, you're going to have 23 parts. Then of course you can add a different type of material. But because my aim here is to show you how to do a bird strike simulation, not to get an accurate result. So I'll try to make examples simple. So keep this one as a single part and go to scale times this one to 0.001 to make it meter, because the model is in millimeter, and then click on OK. And then here Abaqus says that it will try to repair the part. If there is any problem, say yes, and just ignore this error, doesn't matter. So now we have our wing. Next one, I'm gonna add I'm gonna actually create a bird. So I'm gonna say part create bird 3D deformable solid, approximate size 0.5, and then click on continue. Here for this tutorial I'm gonna use a cylinder shape. So the radius is going to be 0.05 and the depth is going to be 0.15. So this is our bird, and then I'm going to add the domain as well. So this is going to be domain, which is going to be Eulerian method, and make this one 2 meter. And what we can do, we can create these construction lines, and then I'm going to fix them. Then I'm going to use a rectangle from here to here, and then give a dimension to it, 2 meter, from here to here, 1 meter, from here to here, 1 meter, from here to here, 2 meter, cancel the dimension, click on done, and for a depth add 1 meter. So this is our Eulerian domain. So we have a bird, domain, and wing. Next part, we're going to create a material property. So first I'm going to start with a wing. I'm going to make it completely out of aluminium. So density 2800, and for elasticity, elastic, Young modulus 70, E9, Poisson ratio 0.3. And then I'm going to use a Johnson-Cook damage model. So plastic, Johnson-Cook damage model. And then if you go to this Excel file to aluminium tab, you can just copy this one and paste it here. Just add E6 to this one and this one to make it meter unit. This one 1.1, this one 750, and this one 293. And then I'm gonna also add damage as well, ductile damage. So I'm gonna copy all these parameters here, and this is 750, 293, and this is 1. And I'm gonna also add the damage evaluation. I don't really have an accurate value for this one, so I'm gonna consider this one as a type, and displacement as a failure is 15 millimeter, so 0.015 meter, which means that once we reach to that value displacement, the failure will evaluate inside our aluminium part. So click on OK, and then I'm gonna create a section, aluminium homogeneous, click on continue, OK, and then go to wing and then assign this one to our wing, done. Okay, so now we have a material property for this one. Then go for a bird. I'm gonna so this one is going to be bird density 1000, and go to equation of state USUP, and then we're gonna add the material property for this one. This is 1500, 0 and 0. There are in the Excel file, if you go to EOS tab, there are two different material properties. So one of them is this one of them is this one, so you can use either of them. You can find these references here, and just a quick explanation that they normally consider bird like a water, so which means that because they say that we like 80 to 90% of our body is made out of water, so basically they assume that is a kind of like this volume that we have is made out of water completely. So now click on OK, and then say bird solid homogeneous, select the bird and assign this one to this, and select the bird. And finally, for domain, create a new section called domain, go to solid Eulerian, continue, and select the bird material, click on done, and assign this one to this one. Okay, now go to assembly and first bring a domain, and then what I'm gonna do, I'm gonna bring a wing. So this is our wing here, and click on OK, and then select it. I'm going to rotate it first in X direction, so 0, 0, 0, 1, 0, and 0, minus 90 degree. And then I'm going to rotate it in Y direction. So first one 0, second one 0, 1, 0, 90 degree. Click on OK. And now what I'm gonna do, I'm gonna select, make this one transparent, and I'm gonna select this one, create a datum point midway between 2 points, and then I'm gonna select this point. Then I'm gonna rotate this one, gonna go to other side, select this point, and now we're going to have the point in the middle of this wing. And then I'm going to use this transparent translate, select this one, click on done, then select this point, and we're going to transfer that to point 0, 0, 0. So enter, and if you rotate this one, you will see that our wing is located here in the point 0, 0, 0. Now click on OK. What I'm gonna do now, I'm gonna move this one slightly to the right, so translate this one as well, 0, 0, 0, 0, 0, minus 1. This is too much, so I'm gonna say, sorry, 0.15, yeah, this is better. Click on OK. So now we have our wing here in the middle of domain. Now we need to add a bird. So bird is located here. Click on OK, and then I'm going to remove a domain temporarily. So click on cell, get rid of this one, and then zoom in, select the translate, select on this one. We need to move this one in the Z direction, so 0 0 0 and this one 0 0. Let's try 0.15. so if you make it very close to wing is better, because you need a smaller computational time, because once you make it further away you need to increase the time so bird will reach to the wing. So I'm gonna make this one probably this is not this one, so I'm gonna make this one 0 points. Yeah, this one is good, so 0.12. then click on OK, and then bring everything back, so we have this one. Now what I'm gonna do, I'm gonna go to step, create a step for this one. First select the solver, is going to be dynamic explicit, and for a time period 0.05, click on OK, and then outputs, edit this one, increase the number of the interval to 100, and then from failure select the damage initiation criteria for aluminium, and then activate status here, and then you can activate this one for our Eulerian domain as well, these two. So now click on OK, then I'm gonna go to interaction. So here in interaction we just need to create a one general contact, because we don't really know the contact between a bird and the wing. So I'm gonna go to here, initial, general contact, and then from here create a property, contact, continue, and then keep this one as a default, click on OK, add this one, done. Now we are done with interaction. Go to load. First we need to fix the boundary domain, fix the our Eulerian domain, so I'm gonna click on this one in the initial step, the first one, click on continue, select the bottom one, done, and then fix this one in all directions, and then cancel the hide, and then select on this one, go to other, and in step 1 Eulerian boundary, hold the shift and select all these faces, done, and then set the flow, outflow, and make this one non-reflecting, which means that once the like a bird reach to this wall, it's gonna leave the wall, but of course it's not gonna reach the wall, but we just assume that the bird after impact is gonna leave the domain. So now I'm gonna again activate a hide here. Next step is to give a movement to the bird. So what I'm gonna do, first I'm gonna remove this one, done, and now I'm gonna give a velocity to the bird. So I'm gonna click on this, initial mechanical velocity, click on this one, done, make this one 0 and 0 and this 120 meters per second, click on OK, and then we need to do one more step here. If you remember, we were removing a Lagrangian mode body from the Eulerian part with the volume fraction tools, but before doing this one I'm gonna go and apply a mesh, bring everything, and then go to part. First I'm gonna apply a mesh to this one, select everything and apply a mesh, maybe 0.1, yeah, this one is good, assign a mesh, yes, and then go to bird, assign a mesh to this one as well, maybe this one 0.05, like this, yeah, this is better, so 0.01, assign a mesh to this one as well, and then wing. So for a wing I'm gonna apply a mesh to this, and 0.03, yeah, this one is good. Of course you need to apply a finer mesh, but I mean we want to save the time, when we want to run a simulation. So click on OK and then assign a mesh. Yes. So this is our mesh. As you can see, it's not great, but it's good enough to get some result. And then I'm gonna go back to assembly. As you can see, we have a mesh here. And then I'm gonna go to load, and then from tools, discrete field, volume fraction, I'm gonna select the Eulerian part, and then from here I'm gonna select the part that I want to remove, which is going to be bird in this case. So click on OK. Now I'm gonna call this one bird velocity, and then I'm gonna activate this one as well. So this is something new that we haven't done it in the previous tutorials here, because at the end of this tutorial we need to, before running a model, we need to subtract this one. Then once you subtract this one, then the software wouldn't recognize the velocity that you applied there. So now we need to activate this one, node set, so we can give a velocity to these nodes. So what I'm gonna do, I'm gonna change this one. I'm gonna make this one bird velocity. Click on continue, and then edit this one. Go here, edit this, and instead of set to, click on this, and then find bird velocity that we just created, and the type is node, is not geometry anymore. So now click on continue, keep everything as it is, and then click on OK. So this is going to be our bird and velocity on the nodes. So then I'm gonna create a material property for that area. So click on create, other material assignment, continue, and then we need to select the Eulerian part, and then discrete field, select the bird here, bird velocity, click on OK, and now we have the material property for that area as well. So what I'm gonna do, I'm gonna go to assembly here, and I'm gonna dismiss this one, or suppress this one, sorry, and then go to here, create a job, call this one wing CEL number 1, click on continue, OK, and then submit a job. So I'm going to check if we're going to get any error here. So as you can see, I didn't get any error, and this one is not going to take a long time, but still it's going to be, is need at least probably 20 minutes to be done. So I'm going to show you the simulation that I have just done before recording this video. So as you can see, the job here is done. I'm going to go to monitor to show you the time here as well. So the time is 0.05. I ran this one for this time. So I'm going to show you the result. So first thing you need to do, you need to go here and then select the free edges, and then select on a plot here, and then from here, result option, increase this one to 100% to have a better animation. And then what I'm gonna do, I'm gonna go on a stress plot. So this is the stress on the wing, and then I'm gonna go to the first frame, and then from here, section cut, I'm gonna activate a bird so we can actually see the bird here, and then I'm gonna run an animation. So as you can see, when the impact happens and the bird goes inside the basically wing. So the damage here is very sensitive to the value that we defined, if you remember, in the damage evaluation part. So if you make that value slightly bigger, you wouldn't have like this amount of damage. But as I said, I don't really have the accurate value for that one, and this is just for a demonstration. So here you can see the basically bird strike on a wing using a Eulerian Lagrangian method. And also, for instance, we can see the pressure when the impact happens on the wing. And then also we can basically create a section cut like this and see the damage on the wing. So here, for a boundary domain, Eulerian domain, we didn't consider any material property. So we didn't say this one is made out of air. What you can do from what you learned in the previous tutorials and here, instead of having a void here, you can consider it as completely as air, and also we have a bird as well. So that's going to be a closer to the real life example. But mostly what I saw in the papers, they consider this area as a void, because like that bird wouldn't really affect the bird movements is not really affected by air that much. So they neglect the effect of air in the environment. So they consider it as completely as a void. And also you can activate this one as well, EVF void. And then if I go to the first one, so you see that, so this is a bird and the impact happens, and this is going to be our damage. So if I cancel this one as well, we're going to see it in a better way. So this is the bird, and one misses stress, and this is how we're gonna have a damage on the wing. Yeah, this is everything for this tutorial. I hope you enjoyed it, and thank you so much for watching.